All right, let's take a quick look at this. All right, I've got an eagle flying 3.4 meters per second. A fish in a town wiggles loose and falls to the lake 4.4 meters below. All right, so again, it's calculate the magnitude of the velocity of the fish relative to the water when it hits the ground. All right, so we got to calculate its final velocity, and that's this is going back to like the supplemental problem that I put in, homework problem that I put into your notes. All right, it's the same thing. So basically, where am I going? I'm going here. All right, so here's the idea. All right, you're at this height. There's all kinds of ways you can calculate, because you know the initial velocity in the y direction is equal to 0. So and you know the height. You can do the old time-honored thing. Now this only works when flying vertically. When something is flying or thrown vertically, this only works. And we can kind of come up with our own little formula for it, because I know that the change in y is equal to v naught y times t, and v naught y for these things is always equal to 0, minus 4.9 t squared. So this goes away, and so t squared then is equal to the change in y over 4.9 over 4.9, where t is equal to the square root of the change in y over 4.9. You'll see it maybe in your textbook. They might have written it this way, as it is equal to 2 delta y over g. There's another. So you can use that, plug it in, and then to get the final velocity, you do this thing. So let's look at it. Let's look at another problem, since that one went kind of quickly. You can do these vector things. So this one's not hard, because you take this guy, and then you don't even need to worry about this stuff here. You don't even need to worry about this stuff. You just know that this one is 6.72 meters. So that makes it easy. And this total angle is these two added together. And so you're just going to go along here to along here. It makes it a pretty straightforward problem. I'm not going to waste a lot of time on that. So here we go. That one's straightforward. You can do that. All right. That might take a little work, but you can do it. All right, we did this one in class. What speed does the ball hit the ground? Now this is a little bit different, because it's got to go up and it's coming back down. However, you've got the initial speed that it took off. That's going to be the same speed that at what speed does it hit the ground? They're not asking for the velocity; they're asking for the speed. So you go, oh. Well, the speeds are going to be the same. The velocity is going to be different. One's going to have a negative angle. One's going to be the positive angle. Okay, how far does the ball remain in the air in seconds, and what is the maximum height attained in meters? So let's do that one. So, because I already know what this one's going to be. I already know what this is going to be. I bet you I could do it this way. I could go parentheses. $19.5 squared plus 12.5 squared close parentheses, submit. Yep. In other words, the speed is the same, because it's the magnitude of the direction. The magnitudes of the two that is kicked is the same. All right, now how long does the ball remain in the air? let's take a look at that. So this is problem 11, second half. $19.5, $12.5. Oh, we got to find the angle. All right, so now we got, but we don't really. We don't really, because I know what V naught X is and I know what V naught Y is. They gave me V naught X and V naught Y. That's nice. So for problem 11, I've already got V naught X. It's equal to 19.5 meters per second. I already know V naught Y is 12.5 meters per second. Now, we could look at this formula here and go, oh, this gives me T max. If I multiplied this T right here by 2, I would wind up with the time that the ball's in the air, and I could, but let's go ahead and work it out. All right, so I know that this was what it was initially, where it was initially kicked, and so I'm going to get T to the Y max is equal to V naught Y times T minus 4.9 T squared. I don't know what Y max is at all, okay? But if I want to find the maximum height, I can go, okay, V final in the Y direction at maximum height is equal to 0. Acceleration in the Y direction is still negative 9.8 meters per second squared. So I can find the time easy enough. I can find the time because V naught Y minus 9.8 T is equal to 0, where 0 is equal to V final Y max. Okay, so I've got 12.5 minus 9.8 T is equal to 0. So 9.8 T is equal to 12.5 T is equal to 12.5 over 9.8. And that's to get to the maximum height. 12.5. Pardon the drilling, but they're building a new building right next to ours. 1.275. Let's leave this as 1.28 seconds. So the range will be V naught X times 2.56 seconds, because T total is equal to T max, because this is T max right here. It's equal to 2 times T max again. So I got the range. That's easy enough. And, oh, so the range comes out to be 0.5 times 2.56, 49.92 meters. And then the maximum height, I can just plug this T into here, and I should get it. So I'll plug this guy into here, and I've got it. Then I'll show you another way to do the maximum height too. $7.97. All right. Worked out like a charm.